What I would like to do is use the u or any notation you like, it doesn't matter. So I'm going to say let u be x squared plus 21. As long as du is easy to make. So the integral, you don't have to copy this, but I just, it's easier for me to explain. So I have an x squared, I have an x, I have the square root of x squared plus 21, and I have the x. I broke x cubed into this product. Why? Because I see an x and a dx. So this piece with this piece will make the du, but there is one little thing that I have to take care of. That's not a big deal. So now these three pieces will form the du. Let's see what is left. Well, this is very clear. It's going to be the square root of u, or u to 1/2. Now the question is, what do I do with this? When I move from x to u, all x's have to go away. But I cannot erase anything. I have to just, in terms of u, change everything. So what should I do with this?
You could rearrange the u substitution to solve for x squared.
Yes, u minus 21. Excellent. So I have to have the 1/2 in front. These three pieces will be du. This one will be u minus 21. And this one will be the square root of u, or u to 1/2. At this point, I have to distribute. So I have 1/2. The integral from power 1 plus 1/2 is 3/2 minus 21 u to 1/2 du. And this is 1/2. U to 3/2 plus 1, so 5/2 over 5/2 minus 21, 1/2 plus 1, 3/2 over 3/2. It's an indefinite integral plus a constant c. It will give us a family of functions. I have to flip everything here, and when I do, I get 1/5. U was x squared plus 21, has to be replaced, and minus 42 over 3, and I can divide that. So x squared plus 21 to 3/2, and plus c. And this is 14. So I should rewrite it as 1/5 minus 14 plus c. So every time I use a substitution, I have to make sure that everything is accounted for. So these three pieces were accounted for, this one was accounted for, now I need to do something about this. Now, if this is x cubed, then my substitution doesn't work, and I will not be able to solve this. Not at this point. Next question. Is this okay? Any questions on this problem, or let's move on to the next? Normally, I didn't mean to confuse you, but in the last 20 years, the student opinion forums opened 2 weeks before the last day of classes. I thought that there was now no change, so there may be a change. So very soon, today, tomorrow, they will open them. But I can't say when. So the offer still stays. Next question. Anything you'd like to ask? WebAssign or not?
Can we look at now the book?
Anything, yes, I'm ready.
5, section 3, question 56.
So let me close this up. So which section?
5.3.
Okay.
In the book.
Oh. Is my computer embarrassing me again? Let me give it some juice. Maybe it's getting upset. Yes, which one?
It was question 56.
56. This one. Oh yeah, very good. I wrote solutions. I'm very proud of myself. So I'm going to stop sharing. So when we graph, so between y equals 0 and x equals 1, this function x cubed looks like this. I don't care to graph the whole thing because I'm really interested in between these three. So the area has to touch these three pieces. Has to touch the x-axis, which is y equals 0. Has to touch x equals 1, and has to touch x cubed. So this is the integral from 0 to 1 from the upper function minus the lower function. But x cubed minus 0 is x cubed. So then x to the 4th over 4, from 0 to 1, I only plug in 1, 1/4.
Okay, so it's just that little slice of the graph.
That's it. Yes.
Okay, thank you.
Thank you. So before you find the next problem, let me just summarize what to expect on this test. So number 1, Riemann sum. Number 2, approximate. Of course, this is for linear, quadratic, cubic. Approximate the integral from, let's say, 0 to pi over 6 from sine squared dx, sine squared x dx. We cannot find an antiderivative. You cannot exactly determine this. Let's say using 4 subintervals, and I ask you to choose one method. I don't want all three. The leftmost point, the rightmost point, or the midpoint. Next, definite and indefinite integrals. Properties of definite integral. Total change. Like, for example, the total change could be the total distance. The integral from t1 to t2 from the absolute value of v of t dt. So when I say definite, of course, I also talk about the fundamental theorem of calculus, part 2. And also here, fundamental theorem of calculus, part 1, in which I'm given, let's say, g of x is the integral from x squared to tangent x from x squared, t. Has to be a different variable. T squared dt. To find g prime. Find g prime. I cannot think of anything else.
Were we going to have the slant isotopes?
Say it again.
The slant isotope?
That's for the final.
Oh, okay.
Yeah.
Thank you.
So I'm looking through the book. So antiderivatives, I forgot, 4.9. They are included, but so antiderivatives. So 4.9, the antiderivatives, 5.1, limit of the Riemann sum, areas with the Riemann sum, properties, Definite integrals, indefinite substitution rule. That's it. There is nothing else. Just to make sure. What would you like to continue?
We do another Riemann sum.
Yes. Let's choose a function, any function you want, but it has to be linear, quadratic, or cubic. And give me an interval. And then we can check. So we want a function. Don't let Mark say anything. Just kidding. Just kidding. Any linear, quadratic, cubic, and an interval. If you want to be nice, you'll start at 0. You know what I mean, quote unquote. It doesn't matter to me. I can always check with the definite integral and I'll find my mistake. Unless Jordan helps. Or Mark or Jordan. We need a function. Please. Anyone? Okay, 3x squared plus 2x minus 1. And let's say 0 to 6. Okay. So the preps, delta x, 6 minus 0 divided by n. Nice. Number 2, xi is always 0 plus I delta x. Always. This number plus I delta x. But since it's 0, I times this is 6i over n. In step 3, I have to plug this in to get f of xi, which is 3, multiplied by this squared, 36i squared over n squared, plus 12 I over n minus 1. After this is done, I can say that the area is the limit as n approaches infinity from the sum from I equals 1 through n, from the first subinterval to the last subinterval, from delta x, allow me to put it already in front because it does not depend on I, times f of xi, which is all this, and I will multiply. So I think I have 108 I squared over n squared plus 12i over n minus 1. Okay. Now, one property of the summation notation says that sum of this plus sum of this plus sum of this. But when I do that, because I'm lazy, I will take the constant in front of the sum already. So I don't have to write it 3 times. And this is just the sum of 1, which will be n. Okay. So this is limit as n approaches infinity, 6 divided by n. 108 over n squared, the sum of I squared, plus 12 over n, the sum of I. And then the sum of negative 1 is just simply negative n already. Of course, from I equals 1 through n, from I equals 1 through n. Now, this, and do not cross them out like that, I'm just making a point. This will be replaced by n plus 1 divided by 2. And this one is the ugly one, n plus 1, 2n plus 1 divided by 6. Okay. Let me see how long with the time here. It's 14.